How's everyone doing?
Hi.
Yeah. You enjoyed the talks today? Yeah. What were some things that you really liked? Any particular presentations or things you learned? G-data? Yeah, G-data is interesting. There we go.
I have a little question
Yes.
on the way that Gears
Uh-huh.
manages diffs between versions of Google Documents
Mm-hmm.
or something like that.
Yeah.
I mean, I have a local version
Uh-huh.
and I work on that local version offline.
Uh-huh.
Then I work on my online version
Okay.
without doing the sync, you know. So I have a different version from local,
Uh-huh.
okay, and online version, but with different modification changes.
Right.
And which is the version, the main version, and the merge between, always under the merge between the two documents.
Right. So the question is basically about merging
Yeah.
in Google Docs. So the thing I know about both Google Docs and Zoho Writer offline, which has a similar situation, is that they don't do merging. They attempt to take the most recent document.
So
But-
I can lose changes.
Well, no, because they'll be saved as an older version. So it's there as an older version.
There are revisions.
There are revisions. Yeah. So I don't completely know deeply about that area, but I believe that's how it works. So cool. So let's get started. Today I'm going to talk about creating a client-side search engine with Gears and Dojo. And I just want to know who came to the morning Gears talk? Just to know background. Okay, so it's mostly a new audience. I'll have a short introduction to Gears, but this is going to be an advanced talk. We're going to dive deep. You're going to see, we're going to weave deeper and deeper and deeper where you'll see using Gears and a pretty advanced scenario. And at any time, please, if I'm going too fast or you don't understand something I've said because of translation, please raise your hand and I'll answer any questions. So my name is Brad Newberg. I work for Google. I work with the Gears team and with the Dojo project. It's an open source JavaScript toolkit. And the agenda for today is first I'll give you an introduction to Gears because it sounds like only a few folks were at the morning talk. Then I'll talk about PubTools search. And this is really the focus of today's talk. It's the demo. It's what we'll go deep into. And I'll talk about how to use it. And then I'll give you an introduction to some of the Gears modules that it uses. Then we'll talk about the search architecture. So you'll kind of see the high-level architecture that PubTools search uses. Then we'll talk about Dojo. So you're going to walk out of here with a basic introduction to Dojo as well. And you're going to see real code snippets from PubTools search. And then I want to share with you some tips, tricks, and code for Gears best practices, best tips when you're working with JavaScript in an advanced way. So let's get started. I want to begin by what is Gears. So who was here, who got to see the Open Web keynote? Okay, so a few as well, so I'll repeat this material. So what is Gears? So it's an open source browser plugin that hooks in. And today, the situation is like this. We've got JavaScript, CSS, HTML. We've got the web browser, but it's sitting on these machines that are very powerful. And yet it can't access a lot of what's there. We have 100 gigabyte hard drives. We have multiple CPUs now, but the browser is, let's see, I said Commodore 64 this morning. The browser is forced to run like it's a, what's another old machine? Amiga, which was pretty good actually. But it's forced to run like an Amiga, but we have these very powerful machines. So what Gears does is it has these modules that in a safe way expands what the browser can do, allowing you to use multiple CPUs, allowing you to really use the storage capability of these machines. And what's important is that it hooks into today's web browsers on mobile devices like Windows Mobile, Firefox, Internet Explorer, Safari. So it's a way to get new abilities into current web browsers. Now, who here has heard of HTML5? Okay, so HTML5 is the new version of HTML. We have HTML4 today, and it's got all sorts of cool features. One of the problems on the web, you've heard of XML HTTP request, yes? When was that invented? Yes, 1997, 1998. Actually, Microsoft invented it. They were the first ones to do it. How long until it was in enough web browsers that you and I could use it? 2005. So about 8 years? Yeah? My math isn't that great, right? If we have to wait 8 years, 10 years for any new thing, that's not good for the web. So the great thing about Gears is it's a way to get new things into the web. So HTML5, as it's developed, you will see that Gears will become a way to get those features into today's web browsers. So you can use them in IE 7, Firefox 2, Firefox 3, right? So we can go faster. And the final thing about Gears is it's open source. It's an open community. You can get involved. You can download the code. You could build it. So this is your insurance that will keep us honest. So Gears is fully open source. So I've spoken about that Gears extends the browser. So some of the modules that it does, I'm not going to get, the introduction, we went through most of the modules. I'll just touch on the ones today that the sample uses. One of the modules is a database. This is a real relational database. It's SQLite, has SQL storage. You can do some really amazing things with it. Another Gears module is called client-side search. This is the ability to kind of do what Google does as a search engine, but on the client side. So you could store data in your database and then search over it very fast. There's a worker pool, which is a way to run JavaScript code without blocking the web browser. There's geolocation, and you may have heard of the announcement today. What geolocation is a way when a user gives permission that a web application can get the longitude and the latitude. And today what we launched was the ability for Gears to use a Wi-Fi network, if present, to figure out your location. And I won't get to talk about geolocation today, but that's really cool, because what geolocation does is it'll use GPS if it's there, like on a cell phone. But on a laptop, it'll use Wi-Fi and figure out the location globally now in many cities. The desktop API, this is a way to drop a shortcut on the desktop so that a web application can be started easily, just like a desktop application can. Local server is how you go offline. It's the secret to going offline with Gears. And so there's other modules. Gears is constantly growing. There's new modules. So we're only going to get to talk about a few today. So the bulk of today, I want to talk about PubTools Search. So what is this? It's important to say this is not part of Gears. This is an example application. It's a very simple open source library I created to teach you about Gears. And what it allows you to do, it allows you to drop a client-side search engine into your page. So let's start with a demo of what this looks like, and then we're going to go into the code. All right, so it's going to happen really fast. So when you see this, PubTools search takes a list of URLs to download. Let's grab those. That you give in a simple file. So this is a list of books. Each of these points to a full book in textual or HTML format. And it literally downloads those and indexes them using gears into the client side. So it's going to happen fast. You have to watch it. When I click this, you'll see quickly, processing. See that? It only does that once on page load. It grabbed that file, downloaded each of the URLs, pushed them into the local database in the client-side search, and then now they're local. And I can search in real time without going over the network these books. So it's Descartes, Montaigne, so we look at Descartes. The book is there. So it's fast because it's local. What's another term? So we've got, right here, some of the books is Politics, yes. So Montaigne, we see Machiavelli, Emma Goldman, Plato, look at Machiavelli. So there's the book. And so I'm going to start by showing you, this library makes it really easy for you to do this, and I'll show you how to do that, because you can use this in your own work. So let's actually look at how this is used. So what you do, here is the HTML for what you just saw. All we had to do was drop 2 JavaScript files in. This is part of PubTools search. We drop a style sheet in so it can display the results. And then in our HTML, we drop a special div with a magic ID. That's where it's going to put the search field. And then we give a list of URLs. So this could be anything. It can be text, HTML, XML. So it could be employee handbooks. It could be anything you want. And you give a version for all of these. And PubTools search will download all these, bring them in. And so to use this library, very simple. You just do what you just saw, and now people can search locally. So before I jump, I want to make sure everyone understands what they just saw. So PubTools search works on the web. You put these things on a web server, it downloads it locally. All the search happens locally. And so a normal user can just do that locally. So does that make sense? See? Yeah. So a common question is why? Why do you want to search locally? Well, it's fast. If I wanted to do real-time search, I'd have to send it over a network and come back. If I download some subset of documents, I can do it very fast. So there's no network latency. Yes?
Did you index a single paragraph or just the whole documents?
Yeah.
You return the whole document or just that snippet?
So it just returns a snippet. Well, so when it indexes, and we'll go into indexing, we'll go really deep into that. It breaks it down into words and builds up a special data structure. Gears does most of the hard work for me. But when we search, we show a snippet. So you see the word politics, and it shows little snippets where it matches that word within a large book. Yeah. So no server. You just have to store these on a server, but then the hard work happens locally. And again, it's your documents. This is like literally in 5 minutes, you can make a custom search engine that's using your documents. So that's pretty nice. And finally, it's simple. And one of the big reasons is this. It's a really nice Gears and Dojo example. It's sufficiently complex that we can really get into some real issues, but it's not like trying to build Gmail. Right? So it's an interesting example that we can build. So again, just one more time how to use this, and you can download this library. It's at code.google.com called Gears Pub Tools. You make that simple file, search.txt. You just drop this in your page, the CSS and JavaScript. Add that magic div. And then if you ever want to add something or change something, you just change that file and bump the version. That's it. So that's just that little bit of work to get a client-side search engine. That's pretty cool. Yes?
I haven't seen the Dojo files.
So Dojo's in there.
It's inside the library.
Yeah, so Dojo doesn't really get in your way. I mean, it's used as, this project got sufficiently complex, and we'll get into source code. So we're starting light. But Dojo's used to organize things, and so a user wouldn't see the Dojo. But when you're changing the stuff, Dojo's doing that. Any other questions?
Yeah, how much heavier are the files you downloaded?
How heavy are the files? In what sense?
I mean, are they 1 mega?
No.
100?
Books tend to be pretty small, really, when you turn them into text. I think there's several hundred K. Each of them are 50, 100, 200, 300 K.
So when I want to search a large website locally, I can.
Yeah. So the question is searching a large website locally. So there's using this library, there's a magic spot. You probably don't want to download, I don't know. Yeah, exactly. The whole library. But there's a sweet spot, probably 50 to 100 documents, several hundred K each. You don't want a user to have to wait a long time to index. But you saw the downloading was fairly quick, and the indexing is pretty fast. So, yes.
I just downloaded the demo, but it doesn't seem to work.
I'm sorry. What's that?
Search demo of Pub Tools,
Uh huh.
but it doesn't work. It doesn't work in Firefox. It doesn't work in Internet Explorer 7. And I just saw an open issue saying stuck at processing 40%, which is exactly what happens to me.
Cool. Sounds like a bug.
Yeah. August 14th.
Cool. Well, this is great. After the talk, maybe I can figure out your environment more, and we can isolate the bug. Okay, so Gears modules. So I want to talk about the modules that are used. I apologize to folks who were here in the morning, but we're going to talk about the database, the worker pool, and the search, because you'll need to know that when we get into the code. So the database, I spoke about this in Gears. This is a real relational database. It's SQL. So who here has worked with SQL or relational databases? Okay, great. And this is a real database. Has triggers, virtual tables, a large amount of SQL, and has a tremendous amount of storage capacity once a user gives permission. And it's important to note that one website can't read another website's database. It's secure, right? Websites can't steal your data. So this is safe to use that way. In terms of the code, you'll commonly see this. You have a factory. This is JavaScript. You have a factory where you create the module. You open your database. Executing SQL is very straightforward. There we are creating a table. Inserting is very straightforward. We're adding 2 values to 2 columns. Iterating is the same thing. We get a result set. So here we are getting everything from a test table. And then iterating over it. So while we have a valid row, we're grabbing the 2 columns of information. We're jumping to the next one. And then whether there's an exception or not, we catch and we close the result set in the database. So full text search. Again, Gears bundles a special module inside of SQLite called FTS2 for full text search. To make something searchable, what do I mean by searchable? That means it's a very efficient data structure that you can search over fast. Here's the syntax for making a searchable table. We make a virtual table. Here's how you match something. So really the magic is the match keyword. So we're matching the word tomatoes, which will search. And you can actually do pretty complex queries that you see right down there. Dish, stew. I'm just waiting for the translator to catch up. Good. So worker pool. What are these? So this is a way to run code that doesn't block your web browser. So the way that web browsers are written today, the JavaScript runs in the same thread as the user interface. And if the JavaScript does a lot, the browser will lock up. I'm sure you've seen that as you've used web applications. So workers are not threads, but they're like them. They run without blocking the browser. And here's what the code looks like. So the first thing is we have a factory that makes a worker. And the way that workers communicate with the browser and the browser communicates with workers is through events, through messages. So the first thing we do is we set a message handler on message that will receive the value from the worker when it's done. Right here we have an algorithm that would be intense, like finding a prime number. That's what you're seeing here. So we've got our code that will run on the worker. So like next prime. And then you'd fit some big algorithm in there. And then when you're done, there's a magic method called sendMessage, which sends the result, like the next prime number, for example, back to the browser. And then right here, when we create our worker, we have to pass a string in that's the code to run. So we're doing a trick where we're turning the next prime function into a string and then executing it. And then we pass it into the worker. So now this will run, and a worker can access the database, it can talk on the network, it can do a lot, and the user's browser will stay responsive. Okay, good. So we're past the introductory material. I know some folks who'd seen that already. So we're going to go deeper and deeper and deeper. We're going to start with the architecture of PubTools Search. So let's just put all the classes up here. So when PubTools Search it gets to a certain size, doing a JavaScript object-oriented programming starts to make sense. And so one of the nice things about this presentation is you'll get to kind of see some of the tricks for doing larger scale JavaScript. So these are the classes that we have on our system. So when I do object-oriented programming, I like to have each class have one clear responsibility. So the Search Tools class is a singleton. And its responsibility is to, you ask it, hey, search. And here's a query. And it also handles errors. And you'll see, one thing to remember with JavaScript is unlike Java, there's no real access control. I can't have public or private. So the style is to make protected methods have an underscore at the beginning or the end. So in whatever language you're in, encapsulation matters. So we're just trying to encapsulate the parts of our system. So you can kind of see the public methods on the outside, that's the contract. And then the ones with the underscore is the implementation. Then we have a UI class. And the job of this is to draw the user interface. So the job is to embed itself into the page. Remember you have that magic div? To give the user some status feedback, to show some results. And you see it takes an array of results. The search manifest class, this class represents that search manifest file. Remember with the list of URLs and the version? Its responsibility is to grab that, download it, and parse it so that we can work with it. The documents class, its responsibility is to take a list of URLs, filter them. It will actually find out the MIME type, and I'll explain what that is if you don't know what that is. And then it will download the contents. The indexer class, its job is to take an array of downloaded documents and index them. Pretty straightforward. And then the searcher class, what do you think it does? Searches. And it's responsible for generating a snippet. So you know, like when you do a Google search, you get a nice little snippet that grabs some text of where it matched and bolded it. Well, we now need to do that on the client side, so that class does that as well. So these are the overall classes for the system. Are there any questions about this? And we'll go deeper. I'll show you the control flow. What about what's going on here? Cool. Yes?
Each line type starts supporting.
So HTML, XML, and text. And the reason we need the MIME type, as you'll see, is when we're indexing, we want to get the title. When we do snippets, so having the MIME type is useful. And we also want to throw away things we can't handle, like a Microsoft Word file or a PDF. So we don't try to do something weird with it. All right, so we're going to look at the flow. We're going to start with indexing, and then I'll talk about searching. This is really where the bulk of the system does its work. And the format is you'll see a little rounded box for the class. So we start with the search tools class. That's our singleton. It's our entryway into the system. So for indexing, when the first thing we have to do is we have to get our database name, right? Remember when we make a Gears database, we generate a database name, and you'll see that's not quite as straightforward as you'd think. You don't want to hard code a string, and I'll tell you why later. Then we want to create our database tables, right? And then we want to wait for the page to finish loading. And you're going to see different symbols, little async. That means that it's asynchronous. That means that, we start it, and then we have to have a listener for the results to come back. Then we have the UI class. We create that. We tell the UI, initialize yourself, and it handles the details. We come back to the search tools class, and we want to get the search manifest URL. So by default, it's search.txt. I didn't mention it, but if you wanted to change it, you could create a meta tag in your document. You know the meta tag? Say meta, name equals search.url, content equals whatever, if you wanted to override. By the way, this is a really great pattern. If you're ever creating your own JavaScript libraries, it's good to create defaults that auto-magically work, and then to use the meta tag in a nice, clean way if someone wants to override. So we grab the search manifest URL, which you can imagine we just grab the meta tags from the document, look at the one with our name, and then we get the value. Once we've got that, we create a search manifest class, and we initialize that with the URL, and we say, go and fetch the file, and then parse it. And this is asynchronous as well, right? Anything on the network is asynchronous. So once that comes back, we have a question. Do we need to index again? So we grab the version number from the file, but search manifest encapsulates us from, we just say, give me the version, and it gives it to us, and it's already parsed it. If it's this, we persist it in the database. So we can say, does this version in the manifest match our database? If it does, we're done. If there's nothing in there or it's different, then we need to reindex. So obviously, now, okay, we're going to index, right? So now you're going to see new symbol. Whenever you see that, that means we're working with the Gears database. And we persist the new manifest version. Remember you saw version equals 0.8 at the top of the file, or something similar? So we save that value. We have a table. We'll go into the tables in the database that is a metadata table. And then we create a documents class. And we filter the URLs by MIME type. So just in case you don't know what MIME types are, they're short strings that describe what a file is, what type it is. So GIF, JPEG, HTML text. And the way we filter these URLs is we actually do what's called an HTTP head request. So what that is, HTTP GET requests normally go to the server and fetch everything. An HTTP head request goes to the server and just returns the server response, but not the file. and that gives you information about the file, like caching information, the MIME type. So this class takes that list of URLs and does HTTP head request on each one, and gets back the MIME type. And then it keeps that, and it throws away things it doesn't know how to work with. So I don't know what Microsoft's word is, but if it comes back and says x-application/MS Word, I believe it's something like that. But we don't know how to work with that. But if it's text/HTML, then we do, yes.
Yeah, for every document we have two HTTP requests. One for the document and one for the head.
Yes.
Okay.
Yes.
We can also have one, maybe.
Yeah, but just in case, I mean, if it's a large binary file that someone accidentally put in, it's a good question, good comment. Okay, so now we filtered. For HTML, XML, and text documents, download the documents, and that's asynchronous. So what's interesting is once we have that, we're downloading the documents. We don't wait for all the documents to download before indexing. So why do you think we don't wait? Instead, what we do is as each one comes in, we index it. So why do you think we interleave it?
Because while we're indexing, the gears downloads the other file.
Yeah, yes. Yeah, so over and over in computer science, different things have different performance characteristics. The network is always going to be slower than the hard drive. And the CPU is always going to be faster than the hard drive, right? So we're going to be waiting lots of time in between the download requests when we could be doing lots of work so that the user has the experience of better overall performance. Because most of the time you're waiting on a network. So we use that time to index each of the documents as they come in. And we make an indexer class. And the indexer class runs asynchronous. And you'll see why. That's because it runs on a worker. And you see a new symbol up here. Whenever you see that, it means a worker. And that's because it's doing things that if you've got a really large book, it may be intense to be processing it. So for example, one of the things we do is we try to extract a title. We only do that for HTML documents now, but we go in, we look for a title tag, and take that out. And then we insert a new full text search row. And this is where the bulk of the work is. And when we do that, it's pretty straight. It's really like one line of code for that. It's just a SQL statement. Gears will kick off and do the full text indexing magic on it. And so we want to have that on a worker so that the browser doesn't get slow. And then when all the documents are downloaded and indexed, we're done. So we'll go deeper. Again, on this talk, I liked sort of like Dante, right? going deeper and deeper and deeper. We're going to go deeper and deeper and deeper, but that's the flow of indexing. Any questions about that?
Yeah.
Yes?
The manifest can be smarter. I mean, each line can have a timestamp, so I don't have to download each paragraph. I can just download the recent each.
Yes. Yes, there are probably lots of ways to make the system more efficient. It's reasonably efficient as a demo. At a certain point, I don't want the code to get so complex that it's hard as a sample app. But you're right. We could record caching information for each one, so we don't have to redo everything. So, yes?
And what about disk usage? And the time for opening the SQLite database, or Azure file, or a large amount of data?
So what's great about the workers
Yeah.
is, and you'll see when we get to tips and tricks, if we don't use a worker, it can be quite slow, but if it's on a worker, the browser just stays the same. So the performance is good. Yes?
For the downloading of the file,
Uh-huh.
it will be using the same HTTP stack of the browser?
Actually, Gears has an HTTP request module that you can use on a worker.
And it has the same limitations?
It has the same, it does, yeah.
Yeah,
Yeah, you can't get around the connection limits, which would be cool. Okay, let's jump on to searching, which is a little simpler. The UI class, the user starts typing a query, and it sees that the user wants to search using a query string, right? Start typing the word history. That then calls search tools, which has a search method, passes that in each time the user presses a key, and this causes the search tools class to kick off a search. And it does that by making a searcher object, which also runs asynchronously. And the bulk of this is the first thing it does is it executes a query against the full text search index. Takes the query and executes. It gets back a list of matches, and then for each of the matches, it generates a result snippet. Again, this runs on the worker. And it's not intense, but it's fairly intense. And it's one of those things that shows how cool workers are, because it's doing a lot of string processing, but things go really fast because it doesn't block the browser. Then the worker, what's nice too, I want to just show this, workers can be awkward sometimes. So having a class that wraps them, like the searcher class, protects the rest of the system from seeing that complexity. So we just create the searcher class, give it a callback and something to search, and then when it does its thing in the worker, it'll call our callback with an array of the results ready to work with. And our UI takes that and displays the results. So again, this isn't, I always love, you can do real software engineering with JavaScript. People always doubt that. But this is doing good information hiding of the parts of your system. And we're done. So that's searching. It's really straightforward. So I want to briefly talk about Dojo, and I want to introduce you to various parts of it, and we're going to use real source code from PubTools Search to teach you that. So what Dojo is, these are the two founders. I just wanted to put some bling. Does that word translate bling into the presentation? Alex Russell and Dylan Sheeman. What is Dojo? It's an open source JavaScript toolkit. This is the URL if you want to grab it. And it's actually 3 pieces. So there's a core, which is very small, which will do a lot of stuff for you. You just drop it in your page. There's something called Digit, which gives you user interface widgets. And then there's Dojo X, which are plugins, extensions. So you can do all sorts of cool things from if you were at the Open Web Talk this morning, things like graphics, storage. It helps you with a lot of different things. Dojo includes a build system. You don't have to use it if you don't want it. You just grab the core. But what's really nice is when your project starts to get larger, Dojo has tools to make what you're doing fast and efficient. So it has a build system where it can take your JavaScript, merge it together, really make it efficient and small and compressed. I won't go into that. Who here has used Dojo? Okay, kind of. I won't go into that because it's more advanced. Well, actually I will. By default, whenever you call Dojo, the JavaScript things start with Dojo. So like dojo.get. Because PubTools Search, I wanted it to be able to use an arbitrary web pages where Dojo may already be there. I did some magic with the build system to rename space the Dojo element to be the word pu for pubutils. So normally you'd see something like dojo.hitch, but instead you'll see pu.hitch. And this means that PubTools Search can live on the same page as your own project that might already be using an older version of Dojo or a newer version. So that's a little bit of magic I did with the build system. So let's jump right in. We'll start with doing XML HTTP requests, the magic behind AJAX. This is actually the download method. Some of it's snipped out where, remember we have the documents class? It downloads our documents. So this function takes an array of URLs to download and downloads them. The first thing you see is we actually create an indexer, and we just tell that indexer how many documents we have. Why do we do that? Well, everything runs asynchronously, and the indexer needs to know when it's done. So it keeps an internal flag of how many documents it's downloaded, and then it knows the total amount. So when it's done, it can call a kick. So one thing that you'll see, especially when you're doing something that's very asynchronous, it's easy for your code to get really complicated. So a lot of the tricks you'll see is to make asynchronous code easier to read and maintain. The next thing you'll see is you'll see for each. So this is a dojo function that will take an array and then it will execute that function for each one. And it passes the entry in. So entry will be a URL to download. So you see the array passed in. Each entry has a URL field and a MIME type field. Remember that MIME type came from the filtering, the head request. And then we get to the magic that Dojo gives. So there's a method called xhrget that just gets something. It's really straightforward. You just pass it in what's called an object literal, right? We give it the URL, and then we give it two functions, a load function that will get called when the data comes in, and an error function if there's an error. And the load function, we just call our indexer. Remember we talked about that? Give it the URL, the MIME type, and the data. Internally, it does all that crazy worker stuff, but we're encapsulated from that. And if there's an error, one of the things I like to do, again, if you're doing something that's really asynchronous, you want to centralize your error handling. It'll make your code easier. So this is that search tools singleton. And it has a handle error method that we pass it in. So it's our centralized error handling. Because we don't want to sprinkle all of our code with error handling. It's going to get really complicated. So there you go. Are there any questions about that particular chunk of code? So declare. Normal JavaScript is fine, but again, when you get to a certain level, you want to start using encapsulation. And JavaScript can be made to feel like an object-oriented language, but the syntax for doing so is a little awkward. Dojo declare is a way to declare a class, a JavaScript class, and then provide methods that are inside that class. And it's very straightforward. Here's actually, again, the searcher class snipped down. First thing you give is you give the name of the class, searcher. You give a parent. We have none. We don't subclass. And then you give your methods. And you give them as, again, these are called object literals in JavaScript. So there's the search function, and there's our two private implementations. So again, this can really simplify your code. Hitch. So let's jump right into this one. Here we are declaring the documents class, and we give three methods for this class. And in our constructor, we want to do two things that are inherently asynchronous. We want to filter a bunch of URLs, and then we want to download them. And when you start playing with callbacks in JavaScript, you start running into lots of tricky things. One of them is, when you're doing JavaScript object-oriented programming, you use the this keyword inside of your methods. If you're not careful, you'll give a callback, things will call back, and the this keyword, it won't mean what you think it does. It won't mean the instance that you were working with. It'll actually mean the window. So what we do here is we execute the filter function, give it a list of URLs, and then give it a callback. And then this is actually asynchronous. When they're filtered, we execute the callback, which would run this, right? There's the download function. Hitch is magic. Let's say that wasn't there. Let's say I just passed in download, which means after this ran, this got called. And I call this.do something. That won't do what I think it does. It'll break. So what Hitch does is it takes an instance and a function and hitches them together and passes back another function. So that when I call the callback, the function will be running attached to the correct instance. Does that make sense? It's a little tricky. So many beginning JavaScript programmers just don't try to solve this. But when you start getting to a system that's larger, you need to start doing things like this. Yes?
Is it the same as binding another library?
Yes, it's very similar to the word bind, yeah. So query, if anyone, who here's used jQuery? Okay, so jQuery introduces this cool notion of being able to use CSS selectors to grab things on the page. Dojo query has the same functionality. And here's some code where we grab the input element, and then we get its value, and we just do it by the class name. It's a little arbitrary. We don't do some advanced querying in PubTools search, but that could be an arbitrary thing. If you've got a bunch of buttons on your page that have a class, you could grab them and then add something on them. And there we are searching with the query we just got. And then it gets really tedious to constantly type document.getElementById. So Dojo has a very simple by ID. So here we are getting that magic. Remember that magic widget? You have to give that name. So those are pretty straightforward. All right, so that's sort of lightning introduction to Dojo with some code. So I want to share some tips and tricks for JavaScript and Gears in general. When you're doing something intense, like the database, lots of networking, a lot of searching over the full text search, do them on a worker. The first version of this that I wrote, I did nothing on workers. I did the indexing with the normal JavaScript. I searched the database normal JavaScript. It took minutes to do anything. Put it on a worker, it's instantaneous. So it's a good tip. As you work with Gears, yes.
We can render Google Maps API with the Gears.
Well, they're separate. I mean, they're not integrated. I mean, they're, but
Worker can deliver Google Maps data and the points to be.
well, a worker can't change the user interface, but some people have used workers to do intense operations. One person had a user interface that had lots of, as a graph and nodes. Whenever you move something, it would have to move things around. So he put the calculation of optimizing where things were on the worker, and then that would just feed over to the user interface, which was really cool. It really sped things up. Well, but there's not any formal integration between Google Maps and Gears. I mean, but if you had some special kind of data, it might make sense. I don't want to go deep into this. Remember I talked about creating a database name? Remember you saw that code and it said opening a database? One of the things you should do is rather than hard coding like a string like my database, what happens if you have other Gears apps or things like that? So it's good to make that name a little more dynamic. And one trick you can do is to use this algorithm. Grab window.location, take out invalid characters like colons and slashes, and then at the very beginning put an app-specific label. So we put PU for PubTools or search, and then you trim it to length 64 because that's the length. So this is good if you're making something that you want to have be reusable. Right? Someone might drop this into a page where they're using Gears for something else, and so it's just safe. You saw this stringifying workers. So there's two ways to create workers. You saw when we passed a string in. You can also create one from a URL. So you can maintain it all in a separate file. In order, to make this more of a maintainable system, we have that indexer class. And the index class has some of these methods, index, index worker, get title. And these functions actually get run on the worker. But I want to keep everything bundled together because it's more maintainable. So over in the index, externally, remember we pass in a URL, a MIME type, and a doc. Internally, we actually build up some script to run on the worker. So this get title method, we actually stringify this method, string. That will actually literally turn into the code there added to the string. And then we create a handler that will get called when we need to start things on the worker, and we stringify the index worker. So remember, again, this class is encapsulating the rest of the system from that complexity. So stringifying workers like this can be something that can simplify your code. Another thing that's really nice, is when workers are talking to each other, you can pass sophisticated objects between them. So again, here's some code. We create a worker with that worker script that you just saw, and then we make a message to send it, give it a URL, a MIME type, a document, and a database name. We used to have to stringify that as well, but that was older versions of Gears. Now you can just literally pass the whole object to the worker, and it will just pass over to the other side. So if you're doing complicated stuff, it just goes over in one packet. So that's a nice trick.
And I can kill workers? I mean,
Yes.
if there is too much computing time or some delay, I can kill a worker?
Yeah, you can stop a
Inside
worker.
JavaScript?
Yeah, yeah.
What's that word? If property is not serializable.
So that's a good question. If a property is not serializable, I think it just becomes undefined. I've never tried that.
Like
You might-
still don't know those.
You might get an error. I've never tried it because I knew it'd be interesting if you tried it and see what happens. If you were to crack open the Pub Tools library, you'll see something. We use a trick called a closure, and these are one of those things that sound scary, but what it means is, okay, we've got we create a search tools and we have a function. And then all those classes we talked about, we declare them inside the function. And then at the bottom we return the search tools class. So again, we're doing encapsulation, we're doing information hiding. Externally, outside the file, one method is exposed, search, if you wanted to make your own user interface, for example. Internally, all of these things, they don't pollute the namespace, the global namespace. Externally, you won't see a documents class or an indexer class. They get hidden inside of this. So this is a good trick, again, to hide your implementation details. Because each of these are really implementation details, even though they have public and private facets themselves. So we're going to end, I'm just going to run you through some methods. So create database tables, this makes the database tables. Same thing, get the database module, open it. Then we execute this right here. We create a table if it doesn't exist. This is the metadata. We version our application. We version our schema. We're not doing schema migration in this yet, but just in case, I version the schema. Like, let's say I push out a new version. I could look at that and then have some JavaScript that upgrades the data. And then we have a flag called finished indexing that we set when we're completely done. What if the computer crashes in the middle of indexing? Well, then this will still be set to false, and that means I'll redo everything. Here we are creating the searching table called client search. We give it several columns that will get searched over, including the content. So that was pretty straightforward. And then we'll look at the index worker. So this gets run on the worker. We pass in the message. Message.body is how you get, remember you saw we passed over that little packet, a URL, contents, MIME type. Message.body will give us those arguments. There's also message.text if you wanted it as a string for some reason, or if it is a string. Then we extract the metadata. I'm not showing you this method, but we use the stuff that was passed in to get a title out of the document on the worker. And then we are going to insert into the full text search table, and this is where it does it. So inserting into the client search, here's the 4 columns, here's the 4 values, and that's it. So it feels like normal SQL, but behind the scenes when you do that, Gears kicks off and handles it a little bit magically because it knows it's a full text search table. And then we close everything. And then we send back, remember that magic method send message? We indicate that we're done indexing that particular document. So this is the last snippet of code. Search. So externally, you give it a query and a callback. We've got our worker script, which will get run on the worker. Again, we'll get our message body, get our arguments, get the query, get the database name, which we'll need. One thing to know is that when a worker runs, it doesn't have access to any other values. So you need to give it whatever it needs to do its work. So it doesn't have access to the database name. So you have to pass that in. Here we are opening our database and then using the query to select any content that matches it. Here's that magic of the full text search. We build up a results array, loop over them while we have a valid row. Field by name gives us each of the columns. We're going to pass these back. We generate a snippet. And again, notice our code's maintainable. Remember, we stringified this method as well. Get snippet. Didn't get to show you the code for it, but it lives on the searcher class as well. And then we build up an entry object, which each of the results, loop through it. And then we send a message back to the browser, hey, we're done. Here's our results. It'll get automatically serialized as an array of these entries. And then you also have to, we just indicate who sent the message if we had multiple, which we don't. We don't have multiple workers. We just have one. And the UI class will take that and then just iterate over the array and display it on the screen. So we've just covered a lot of material, actually. This is kind of like the fire hose talk. If you want to play with PubTools search, there's the URL. You can grab gears here. Dojo lives here. And Google Code is a great place. A lot of the Google things you've seen today, as well as a lot of open source projects. Oops, that's an old screen that flipped in there. Right on. So we've got just 1 or 2 minutes for questions. Yes,
The main Google application, Gmail, Google Calendar are integrated with Google Gear.
So Google Docs is, Google Reader is, and it's being developed for other things. Yeah. One more question. Cool. All right, thanks everyone.